pünktlich um 20. Good evening, ladies and gentlemen. Welcome to TechQuartier, Frankfurt's leading tech community. My name is Sebastian Schäfer and I'm the managing director. I'm very happy to have you all here to a very exciting event. Data is the new oil, and AI will be a mission-critical factor for securing economic prosperity in the future. And Frankfurt, as the leading internet node or internet exchange, internet hub of the world, as an industry powerhouse in Europe, as the continental financial center, and as a strong talent pool of AI talents, but also researchers, strong basic research, applied research, is a wonderful place to host such an AI series, I think. And we have today our second edition, the Smart Mobility, which we are now running with IBM, and I'm really happy to have that with you, Dilek. Thanks a lot. Thanks to all of you, and I wish us a wonderful evening, great presentations, great discussion afterwards, and super networking. I'll hand over to you. Thanks.
Thank you very much. I hope also you have a really great event. Thank you, Sebastian, that we could co-host this event with you together and work with TechQuartier together. It's important for us as IBM to have this kind of relationships, and TechQuartier is really unique in that area, working here together on fintechs, working on startups, and we are a couple of colleagues here, so if you have further questions, we have also one presenter here. We are here, you could discuss with us a lot of subject, and I hope you are liking the subject on AI, because this is really something what is in our heart to bring AI forward in DACH. Thank you very much.
So without further ado, I want to introduce you to Fabian Bruckschen from the e-scooter company from Berlin, Circ. Yes. Very much looking forward to your presentation.
So also from my side, welcome everyone tonight, and thank you TechQuartier for hosting this event and for having me. What I want to talk about with you today is how we at Circ are using artificial intelligence in the micromobility sector. For those of you who don't know, micromobility sector is this idea of solving the first and last mile transportation. So getting users on light electrical vehicles to their final destination or from their origin to, for example, the next metro station. And this is a very specific domain, which became also very famous this year when more and more scooters spawned upon the streets. And therefore it has its own domain-specific challenges, which I want to dive into, and then also the solutions that we at Circ developed for this using AI. So we are a Berlin-based startup, operating in around 40 plus cities around the world, and I'm currently the data science manager, which means we have a team of 6 data scientists that all work in different tribes. So a tribe, for example, is vehicle tech or the operations or consumer experience and stuff like that. And one of my main tasks is figuring out where we have overlapping priorities, where we can essentially benefit from other tribes' work, and so on and so forth. A lot of the beautiful plots that I'm going to show are have been made by my colleague Giovanni Marelli, so I want to mention him here. And additionally to that, we also have a couple of data engineers and analysts, which then make up the whole data team at Circ. Our mission is essentially to move our cities towards being greener, being more sustainable, and especially being better connected. And why do we think this is so important? Because the car, in our opinion, is not the right vehicle for urban mobility. So we looked at a couple of studies, and they essentially say there are around more than 200 billion car trips made each year, and half of them are actually shorter than 3 kilometers. The majority of those are only having one person inside the car, so a single occupant. Additionally, in cities that have more than 1 million inhabitants, there's also a very slow average speed of 15 kilometers. So why use the car for such trips, right? And maybe another vehicle might be better suited. So, for example, the scooter. So now you might say, well, the scooter does not help me to drop off my kids at school, to do grocery shopping, or activities where you usually nowadays take the car. And you're right, because micromobility is more than just the scooters that you see on the streets right now. The scooter is really just the first iteration. It is, like I said, a fun vehicle. It's easy to put on the streets and get people to use it, then collect the data. But it's, again, level 1, and the next iterations might be able to handle cargo, so they can actually transport stuff. They are weatherproof, and so on and so forth. And even with just the scooter, we are already moving in small iterations to improving this by, for example, this is already on the streets, but now we have swappable batteries. So we don't always have to take a scooter back to the warehouse, load the battery, put it back onto the streets, but we can do it while we are outside in the city. And this is already increasing the lifetime of these scooters dramatically. So much about Circ. Let's get down to business and talk about why you're all here for the specific challenges that we have in this sector. So this is a special kind of vehicle. It's not like the car sharing industry. So we don't have, for example, long time series data that we can look at in order to analyze how the fall, how the winter is actually influencing the whole business. It was the first season for most of the companies that participated in that market, and therefore it was kind of tough to actually predict this going down of numbers that we're currently experiencing. Also, since it's a very competitive market and it's a very fast-growing market, there's a lot of data coming in that we need to handle. So we do have our data warehouse, we do have our data lake that essentially handles all of the event streams coming in. But keep that in mind when I talk with you about a couple of the challenges that we face. The first example that I want to show, which some of you might already have seen, is vandalism. So people love to throw our scooters into the water, hang them on trees, hang them on traffic signs. You can't do that with a car, right? It was specific to the scooter business, to having these small electrical vehicles on the street. And this might not be a tough data science challenge that you have to solve, but you can use data to actually solve it. So this is a picture of our internal app that we use to see the state of each scooter for every given point in time. And then we saw that actually in Cologne, at a certain bridge, a lot of our scooters went to the status dead. So they essentially were not operating anymore. Which then, with further investigation, showed us, yes, they're all in the water. So we might be thinking about restricting the business area and make people or restrict people to park scooters close to the water. So all of the red areas you can see here, besides the one in the water, this is restricted area. You cannot park your scooter there. So again, it's not a tough data science challenge, but data helped us figuring out where should we actually react. Another issue, which I want to showcase, is theft. So we are also operating in the United Arab Emirates. And we had a scooter who went all the way from Dubai, took a round trip in Abu Dhabi, and then went even further inside the country. Turns out with an insane speed also. Turns out it was being kidnapped in a car and then essentially driven around. So again, we had to look at the data and then created alerts that ping us when there's weird behavior with our scooters. So we can essentially get notified about it before. So a lot of the challenges that we see are actually challenges that we have never seen before, and we have to come up with quick solutions before we lose more scooters. Before I talk about some of the tougher data science related challenges that we had to face, I want to give you a quick overview of our architecture. So our product is the vehicle, right? It's the hardware that we use, and this has an IoT unit that essentially sends us every event, so just like the pings in Abu Dhabi that you saw, which we then store in our backend. On the other side, we have the people on the ground, which is what we call the fleet management. So people who deploy scooters, people who collect them, or even swap the battery. And all of this is important information that we need to store as well. And then also, obviously, very important data, we have our user who's using the app, who's starting a ride, who's ending a ride, and this we have to store as well. If we go one level deeper, by essentially just looking at the most important observation that we have, which is the ride, we take information from all different kinds of sources. So hardware related, we need to know the battery status, we need to know the distance it traveled, we need to know how fast it was traveling. From a user side, we want to know who actually did the ride. What kind of payment did they do? Was it a voucher ride? Was it a free ride? And so on and so forth. And then this data, this internal data that we have, we want to combine it with different other data sources. And what I want to do next is look at a couple of data sources coupled with some of the technologies or ideas that we came up with and used in order to make it usable for our business cases. So first of all, there's our own historical data. And this is one of our cities where we operate, and what you can see is the expected revenue for all of these areas. These areas are hexagons, and they are in different sizes. So this data might as well also be just the app openings in that city, or the idle time scooters usually spent in one of these hexagons. So it's telling me how long are they actually not being used. And in order to make this usable, what we do is we use a hierarchical geospatial index, the H3 geohash, which was invented by Uber, and helps us to actually have this information on different levels of granularity. So it usually is a hexagon, which is made out of other hexagons, which again is made out of smaller hexagons, and so on and so forth. We then combine this with weather data, because obviously the scooter, being like this light electrical vehicle, the use of it in this sharing economy is heavily influenced by the weather. And with weather, you can look at sunshine hours, average temperature, total rain, wind speed, humidity, a lot of stuff that might relate to your scooter or to the usage of the scooter. And in order to make that usable for our people, we have to reduce this dimension to one single indicator that tells us, is the weather good right now for scooter rides or is it not? So you can use standard techniques like a PCA, just give me a good correlation with like a linear combination of these factors. But what we decided to do is actually do a bit of research and find an indicator that has shown to be very well correlated with good weather activities. So if it shows you how comfortable a weather is from 0 to 100. And then that indicator we can use with our other data to draw insights from that. Additionally, what we want to use is administrative data. That is, for example, here on the left side, you can see population density. And usually when you work with administrative data, this is in very low granularity. So here you can see these squares with one number, but we need it on a way finer level. So we have to break it down again to these hexagons that we're using. And in order to do that, we have to do something like spatial imputation. We have to break it down and then predict in between where we do not really know the information. So again, a technique that we had to use to make it usable. This could also be other administrative data. For example, the density of foreigners or some counts of cars, for example. Another very important data source that we use is map data. So in this example, you can see the type of streets. So for example, if you have an area where there are a lot of cobble streets, it's not good for our scooters. First of all, it decreases their lifetime, obviously. And second of all, it's not fun to ride a scooter on a cobble street. So creating spots where we put the scooters that are surrounded by cobble streets might actually not be a good idea. And there's other map data that we can use. So for example, how many points of interest are around there, how many touristic places, how many green places, trees, or simply the density of restaurants. But in order to work with all of these data sources, we have to have a geospatial database. A database that is fit for actually working with polygons and working with data that's available on several granularities. And then the last but very important data source is actually working with the people on the ground, using their domain knowledge. So we, for example, might suggest to put the scooters in these hexagons here because of, let's say, density of restaurants, density of nightclubs, or something like that. But the people on the ground have a better picture and might put them actually a bit further up north because that's where the big streets is, that's where people can see it, and essentially apply their domain knowledge at the very last level. And in order to make that feasible, we have to be able to explain the models that we apply. We have to be able to, what is called machine learning explainability. We have to be able to tell them, well, this is just a suggestion, and it's made because we think due to restaurants or any other data source, this is a good spot. But in the end, they make the final decision where they put the scooters. And this is the problem that I want to talk about now, which is, in my opinion, also the most exciting one. How do we deploy the scooters in the city? And in order to tackle that problem, we need to know how many scooters do we put where in the city and who actually does it. And this is essentially finding the sweet spot between having no scooters available and over-deploying and therefore standing way too many scooters in the way. Here's one example on the side. It's one very famous tourist attraction in Berlin, Checkpoint Charlie. And this has shown to be one of the most favorite end spots for users. So tourists use a scooter, they go to Checkpoint Charlie, they leave it there, and they don't use it afterwards, which obviously very fast stacks up scooters, and then there are several, 20, 30, 40 of them standing around, which we need to know, and then tell our people on the ground, please rebalance them to positions that right now are more promising for users to take a ride. And so in order to solve this problem, to have scooters always available where they are needed, we divided it into several sub-problems. First of all, for all the possible locations inside the city, we need to know how well do they perform at any given point in time. So we need to rank them in real time. Secondly, we need to know how many scooters should we actually put there. Is one scooter enough, or should we put up to 8 scooters there and they will be gone in half an hour? So we need to know the capacity for every possible location. As a third point, we need to suggest new locations. When we started in cities at the beginning of this year, it was more like a land grab mode. We used people on the ground, and they most likely deployed at locations like the central stations, the inner cities, locations that work well, universities. But now that we have this data, which means our own data and the other data source that I showed, we can actually suggest new locations where we've never been. Because the problem with using your own data is this inherent bias that you only get results where you actually had users before, scooters before. So in order to get rid of that, we want to use other data sources to suggest new spots that might be very promising. And then the last step here is to then optimize the deployment strategy. How do we go to these points? In which order? How many stops can we actually make until a shift is over? And in order to tackle that, we developed a modular dynamic model which optimizes for the likelihood of a scooter being used and the downstream revenue it actually makes. And two things are very important here. I mentioned in the beginning, this is our first season. We didn't know how the fall or the winter are going to affect us, so we have to build a robust model. We have to build a model that now works in the winter, but it will also work when the spring arrives. And also it has to be able to anticipate structural changes when we forecast. So for example, certain events that are going to happen within cities, or if we actually double the size of the fleet in a city, we need to know how to predict based on that. And then again, it has to be editable by the people on the ground. They have to understand, they have to be able to apply their local knowledge, because they know their work shifts. They might know about some local events that the algorithm does not know about, and also they are the last sanity check that can be applied to all of the suggestions that we make. And to boil that down into the modules, is what we did is we first figure out, okay, how do we define demand? Demand for us, for an area, is the combination of this probability of use and the downstream revenue. If we then combine that, we can actually give an expected revenue estimate for every scooter in a given area. So scooter 1 might make that much money. Scooter 2, maybe a bit less. Scooter 3 will not be taken at all, for example. And then this gives us the optimal configuration, which is this capacity that I mentioned earlier. And then having that, we can start with this real-time task assignment, so the routing. And a task in this scenario is, for example, deploy a scooter, just swap the battery, take the scooter from outside the city and put it back into the middle of the city, into the inner city. And yeah, these are the tasks that we have to assign in a most profitable way and saving costs, obviously. So how do we get to this probability of use curve? One simple way is to actually just calculate it empirically based on your history. So we had an area, whenever we put one scooter here, it was always been taken in the next, let's say, 8 hours. So we would say, okay, putting a scooter here, 100% is going to be taken. The second scooter, actually only in 3 out of 4 cases, this has been taken. So its chance of being taken is 75%. This is a very brute force approach, but it gives you kind of a notion how well the probability of use compares to other areas. The problem you have then, besides of the bias that you're introducing, is what do we do with areas that we don't know, with areas where we have never had scooters? And in order to do that, the first thing you want to do is actually make this probability of use curve a theoretical curve with parameters that you can predict. So location parameters that you can forecast. And if you have that, you can either, in a very simple way, apply spatial imputation again, just, hey, if it's between very promising areas, it might be also promising, and so on and so forth. What you can also do is regress on features, so-called geo-features, that you have for all of your hexagons, for all of your areas that you're interested in. And then if you even go one step further, and for all of these, you have even a history of data, so let's say a count of cars that pass through this area, which is what we have here on the lower left corner. So you have, this is 1 week of data, and you can, it's a smooth data set, but you can already see, okay, every day there's some kind of peak that we can observe. Maybe that helps us predicting the probability of use during the day. And then if you go further and transform that time series data into a 2D format, so here on the y-axis we have the days of the week, and on the x-axis we have the hour of the day, you can actually see that Friday, the peak on Friday is actually a bit later than on the other days. And if you create these pictures that have this time information of geospatial features, you can feed them into a convolutional neural network, which you can actually get from someone else and just essentially do transfer learning on the last layers, and then predict the probability of use for all of the other areas. So this is one thing we did, which actually showed to be very successful. And then the next challenge we have is, okay, so now we can predict the probability of use everywhere, but how can we forecast it? And this is, again, where our geospatial hierarchical index helps us, because we have then several layers where we can predict into the future on different granularity, and we can also validate on different granularity, and therefore can build a model that we can be more confident about. And then the only thing that's left is essentially the routing problem. So how, if my warehouse, for example, is here, how do I actually deploy at these points and in a most efficient way. But yeah, this is a couple of network algorithms and also the secret sauce that we apply to solving this deployment optimization algorithm. And this was a lot of input, but this is essentially where I draw the line and open up for questions. Thank you for your attention. Do we have time?
5 to 10 minutes, yeah.
Any questions? Yeah. So let me see. That's true.
Okay, thank you. I have a question. Do you have spotted the accidents and spotted areas where you detected accidents of your scooters? I mean, like, I'm just a pedestrian or I use my bike and I always spot scooters, whatever, perhaps in my way, on the pavement, just laying around. I took a picture of a scooter parking just near to my car, just in case. You never know what happens. And what do? I spot scooters in the pedestrian zones where as far as I know, you're not allowed to use them, but they go very fast, just passing style here in Frankfurt, and you can't hear them.
Thank you for that question. So if I understand correctly, you're asking two things. Like if we observe scooters in use, so actually scooters that are being used currently and run into an accident, or scooters that just solely are on the pedestrian, like on the sidewalk, and also scooters that are really just standing around but in the wrong place. So for example, next to your car. So the question is if we can detect them, or if we do that, and what we're doing against it. So yes, we can use data for that, and we have used it in the past. It's not like we have a running model that essentially always pings us when a scooter is on the sidewalk. For that, the GPS is not precise enough yet. And in terms of two people on a scooter, we were starting to develop a model that kind of predicts the weight of users on the scooter. So hear me out. So what you do is essentially you know the user, which is personal information, so you cannot use it GDPR-wise. But what you can use is if you see that the weight for some rides suddenly doubles or is just more. That could be a heavy backpack, right? But it could be also two people standing on a scooter, which is also illegal. And the way we handle this is we rather give discounts to people for the second scooter if they want to rent another one, because we are not in a position to just shut off the scooter when they do that, because like I said, it might actually be just a backpack or something like that. So to answer your question, yes, I think from a personal point of view, data can be very helpful, especially the gyrometer in the scooter that tells you for your parking situation, for example, if a scooter is lying on the ground. And we had cases where the police came to us when there were scooters involved in accidents, and we were obliged to then supply the data that was like of the scooter that was involved. So there has been cases like that, but again, there's no model in production that always tells us when something funky is going on.
Based on the weight, we're probably going to get a lot of wrong data after Christmas.
Yeah, based on the weight analysis after Christmas, everybody would be heavier. That's true, but I hope not double the weight. That's a big Christmas dinner.
For me, it was a fascinating insight here.
There you are.
In a very professional way to run a business. database, getting all the success factors in a very detailed fashion. Coming to the pure and financials, what are the actual operating costs to operate a scooter per day? What is the average revenue per ride? How many rides do you need to be break even per day?
So yeah, this is first of all a question very tough to answer as a data science manager. We do have information, but also I cannot share all the details you're asking. What I can say is that there are obviously cities that are more lucrative, that are performing better, which usually is actually countries that have a more stable, better weather. But in terms of cost, it really also depends on the city how effective our operations is. So this is something that we focus on. How effective can the people on the ground put the scooters there? How much does it really cost? The advantage that we have here is that all of our operations are in-house. So we can estimate the cost that this takes. And this is one of our main goals actually in the next quarters, to reduce these costs by using more sustainable vehicles, by having this battery swappable functionality, and yeah, essentially being more efficient in the operations team. Not all cities, to finish my answer, not all cities are profitable yet, but some of them are. Some of them are already. That much I can tell.
Thank you, Fabian. Fantastic keynote, great insights, and you see we'll have more questions later. So see you back on the panel in a little while. So now I want to introduce you and ask to the stage Dr. Helmut Müller from IBM, who will give us the second or the Impulse keynote. So thanks.
Hello. Thanks for having me here. And I have only 10 minutes. Yeah. Okay. So I want to start with some remarks on what I'm talking about in the moment. At first, we are not in the car business. That means, as in opposite to Google, we are not producing something for the cars. We are offering services to the customer who produce cars. That's a big difference in all that what we are talking about in the moment. And therefore, I think you should always be aware of that. And the second point that's very important for us is that the data we use from our customers are given back to the customers or destroyed after the project. Therefore, we have not the possibility to use the data to optimize our own algorithms. Okay, that's our business model, and therefore you should be aware that we are always under NDA with our customers, and therefore I would say we can have discussions, but I think they are restricted. Okay, I have here some names, therefore I think and the roles, and normally Frank and I'm the central contact points, and the image, you will see it later, has some meaning for the car business. Especially this value of 2.5 terabytes per second, because here we are really talking about big data. So let's start it. And I think the problem with autonomous driving is always that somebody hopes that we will solve this with autonomous driving. What we solve is that you are feeling comfortable if you are in this situation. You're sitting in your car, you can do other things as it is over there, you can sleep, read, work, whatever you are doing. But in the beginning, as long as you have so many different states of drivers, conventional and others, I don't believe that there will be a strong relief in the beginning or in the next years on this point. Therefore, I think we should concentrate on the value that you can do as in others, sleep, read, work, and this will stay the same, I think, the next time on this. But the analytics has already some advantages. I think if you look on all these scenarios, I think there is a lot of points where we could say that not all people are concentrated. And I think we have this point of how old is a driver, is he sleeping, I think about insanity and all this stuff. I think therefore we should not be too pessimistic about what's happening in the market in the next years. And I think the new intelligence will just be another way of microcode that is inside the market. Okay, let's start with the whole stuff. I think from the sensor point, I think all decisions are taken from the sensors. people or the AI can take. And if you look on what a car already can, then you see that the car can look forward, backward, to the side. It has not only cameras, it has LiDAR, it has long-range radar, it has short-range radar. It has a lot of sensors that are producing simultaneously signals to the central system. And that is one point that is on one side very interesting, because it gives it a totally new potential in contrast to the human being sitting in the car. And that is real. I think with the exception of the LiDAR, I think most cars already have this volume built into the car. And why it is important, I think if you are doing AI in a supervised way, the first thing you have to do is to collect the data the AI will see when working. I think we should be clear on that. It means that you want to have all this information for your backend to train your system. You don't want to throw it away. A lot of people are asking me, I want to throw 90% away of the data. Tell me which data is not of interest. And I say, I can only tell you which data is of non-interest when I have trained the system and see that this data is of non-relevance. Therefore, we have a lot of discussion with the customers about how many data to collect. Actually, most customers collect everything. But everything means, in the actual situation, that a car creates 15 terabytes an hour on data, 15 terabytes an hour, and this is increasing because of the cameras. I think the cameras are not in a compressed mode. They are running in pure analogous mode, so that every pixel is produced in the same way it is taken from the camera. And the reason is that the stability of algorithms, I think we are very hopeful that changes in the pixels will not change the decision the car takes, are still, I would say, in some kind, not extremely stable. So changing some pixel might change the decision of the system, and therefore they all want the raw data produced in the car or to the other side. So 15 terabytes an hour, car driving, let's say 4 hours, and you are at 70 terabytes a day. That is run from the car, and there is a real problem in the beginning. I think we are talking about cars in the market collecting data, and normally you would expect there are thousands of cars. But with 10 cars, you are in a range of nearly a petabyte a day. You have to land somewhere, you have to bring it somewhere that you can do something with that. And this is our main problem, to be honest, that we have if we want to do supervised learning. And there's a lot of discussion about the topic to not do supervised learning but reinforcement. But to be honest, all these streams are a little bit, I would say, not in the phase where I would sit in a car that's not trained with supervised learning. This is the main problem we are concerned on. And what we otherwise see is that the rest is as usual. You have on this side, and there's a lot of discussion already on synthetic data. Why don't you use synthetic data? They are using synthetic data. There's not a topic, they are using it since years. But I think, as I said, if the algorithm is relatively sensitive to your input data, using synthetic data makes the problem not, I would say, stable in a sense that you can use it. Therefore, I think you have this sensor data coming from the outside. What you at first have to do is to land it. And as I said, if you are reaching with 10 cars, one location, you have this throughput. I will have later some data on this. Then you have it somewhere positioned, but you don't find anything after 1 year in these data if it is camera data. Therefore, you have to do pre-processing. And the pre-processing is mostly that you can search for video sequences on the base of weather data. How was my situation in the car? How was the acceleration? You want to search over metadata sequences in the stream that is interesting for you. The rest, I think, it is a good idea to early separate training from testing. I think that's totally normal. Then you bring it in, and I think Tesla is one of the camera producers who says, I think the video is enough. And therefore, I think the focus is, in most times, on the video. And therefore, I think the first thing that you are reading here is Caffe, TensorFlow. I think this is normal object detection in videos where you just want to know, I have in my video stream before me a car. On my backside is a car, I want to know is there a person. And I think these are the first things that have to be done so that you can decide what to do. Because I think if you don't have a reproducible way how you operate and you have a law suite, The problem will be that you can't say to the person on the other side, this is what the car did. And you have to have some reproducibility. And afterwards, if you have your model, I think you're bringing it over and put it in production, check what's happening, and the whole cycle is running over. And then the trained model is on the other side, and you are comparing what's happening with your trained model in the market. So what I'm writing here, we are not doing that alone. I think I wrote over there Bertrand, because we are not in the car. We are IBM here with these services. We have business partners working with us. I think what we did is a full circle. And the hard thing is that in the beginning, you can't send the data over the network. Therefore, you have to check out somewhere the disk drives inside the car. You even have problems with the encryption performance, because if you don't write these in the right performance to the SSDs, I think you lose these. Therefore, I think you have to do everything to bring it to the disk inside the car. Then a person takes it out, he sends it via mail or logistics to somewhere that is very close to your backend. And then you are checking in the data. And then you have 4 main functions you have to solve. The first is make it searchable. I don't know if this works. The second is you have to create workflows, because you have a controlled way how the whole solution works. Below, I think this is a landing zone. You have to exchange it. I think the problem is that you have to solve the problem that a car built in Europe has to be able to drive in China, and a car able to drive in China has to be able to drive everywhere. Therefore, you have to exchange your data across the world in some kind, which is not an easy task too. And this is what I'm written here with high performance file transfer. It's a combination over network and over disks or anything else. And below, I think you need the compute resources to make all this work. I think we have an announcement. It's just that you show that I'm not talking about theory, building all this stuff. And I think we had an announcement with ZF, and the focus points are really proven throughput on landing. And therefore, I will show you some data, just that you have an imagination what this means, these data volumes. This is DESI. I think in DESI we have our systems. We have it in Deutsche Wetterdienst, at KIT, and the big computer in Oak Ridge and Leibniz. And if you look what they produce, they put their data to the public. They think about 50 gigabytes per second. 50 gigabytes per second are 12 cars. But our 12 cars are all writing. This is a mixed workload. Therefore, if you look on the largest computer that is in the world available, this is below that Summit, he has 2.5 terabytes per second. These are 600 cars. Therefore, I think what we are confronted with is this extreme volume. And if you look what the car has, I think you only have to predict 2 values: steering angle and acceleration. I think the only thing you are doing when driving, you decide, do you take the brake, do you accelerate, or do you rotate your wheels? Therefore, only 2 values to predict. But the influencing variables are horrible. You are confronted with unbelievable complexity of influencing variables for your decisions. And the only way to handle that is you are training, and then afterwards you are running the whole, let's say, history the car will see in the future. Therefore, you are running the whole stream against your model, because your model is so complex that you have no idea how the model will react. But I think you are confident if it works. You have only testing, change, testing, change. That's the only way to handle that. Therefore, I just wrote it down, because there's a lot of discussion about this topic of AI. What we are really doing in the beginning, what is the real main function is that you are mapping. On the left side, you have your pixel. You split these pixels of your camera in the 3 planes of blue, red, green, and then you have numbers. This pixel has a blue part of 165 in the upper left, and then you are mapping this to a convolutional neural network. This is not a convolutional, but I think it would have made it more complex. And if you look what's then happening, then you have these 3 parameters over there in the network, millions of them. And what you are doing, you present, you know the answer, you check what the system does against the input, you know that, and then you are going back and change your parameters. And that's happening, I think, in the normal convolutional way. And the only point is, I think it might be derived from something that we think is human-made, but it's only, I think, a mapping. I think you can prove that any function, reasonable function, can be approximated in that way. And therefore, what you are doing here is a mass run to have, in minimum, the object detected that are in this that the car has seen. And that is a result. As soon as you have that, I think that in the beginning you have only object detection. Therefore, you know there's a person, you know there's a car, you know whatever. I think you have trained your system to detect all this. And the rest, I think, in the moment, might be more driven by, I would say, controlled workflows. The point is, if you put on top classical AI algorithms on this, I think you have not this reproducibility of data when you are driving changing ways. If you are running this on a car race, I did for a customer, I did a car race. He's running around the same ways. You have 20 times the same running, and then you can look for outliers or something like that. But if you are driving always different ways on different, I think that is not possible to have this reproducibility. I think that is what we, at the end, I think that's the last foil I have, is just, so what we are focused in the moment is more the reproducibility. How do we build platforms or systems that produce outputs that can be reproduced? I think that is more what we are doing in the moment than say, okay, this is the best algorithm. Because we had this discussion. I think the focus on our side is more make it work so that in 25 years you can check what had happened. Because I think the laws are so hard that you have to keep in some kind data and all the stuff for a very long period. Therefore, reproducibility is very important for the automotive market. I think it's just to show you what everybody does. I think with the tools that inside are here is TensorFlow and Keras and all this stuff. I think this is the building phase, and what most customers use is in some kind open source. And nobody has this magic, to my knowledge, nobody has this magic, everything overrolling algorithm in the moment that makes cars drive. I think they are using object detection, all this stuff to make the system work. And that's what I wanted to show to you, because I think I don't have the algorithm too, and therefore I can't show it to you, and therefore this is what I wanted to show you from the car. Okay?
Hello, I've seen last week the CEO of Waymo, and yeah, I saw his slides and thought, yeah, very amazing. But and he also announced that they are starting in Paris next year, so not in the US where you don't have bicycles and whatever. So Paris, I think, is a big challenge. And what I'm asking myself is, okay, what is now PR and marketing, and what is real? So maybe from your experience and from your opinion, how far are we?
If you look on the driven kilometers of the different vendors, I think Waymo is, to be honest, far away. They have driven most kilometers of any other vendor in the market, and I think they are relatively experienced in the possibilities they have. And they are jumping, to my opinion, to the next step to say, okay, I'm focused on taxis, and not to go with individual traffic where you probably have a better chance to optimize the way a car takes. You can control that, and therefore you can optimize probably the situation the car is confronted with. To my opinion, I think they are extremely, I would say, confident and working hard. I would say it that way, and that I think that the other car vendors have to get. I think have to be faster. That's what I think, really. I think all the others are in another class in the moment. That's my opinion, but it's only my opinion, okay?
Thanks a lot. I think that's a first taste of what's coming up in the panel. So thank you, Mr. Müller. Now our third impulse keynote is from Oliver Petrich from Deutsche Bahn. Very much looking forward.
Thank you. Well, yeah, thank you for having me, and thank you for being here and being interested in what Deutsche Bahn wants to do with AI. I'm Oliver. I work in IT strategy at Deutsche Bahn. I'm specialized in enterprise architecture management, so I'm focused on IT projects, IT infrastructure projects, but I'm also part of the Data Intelligence Center, and therefore I want to help to push AI use cases at DB from a strategic point of view. And I want to give you a short impression of what we do with AI, some example use cases, and why we do it. And that's what I want to start with. Today we're talking about mobility, but DB actually is a very large company and we have 8 different business units. So it's not just about mobility, it's also about logistics, energy, maintaining networks, maintaining stations. And every business unit has its own business model and therefore different potentials for the use of AI. And we have many different use cases. And in the bottom of the slide is shown why we think AI is needed and why we think AI has potential for DB. Because the blue line is where we are today, but we want to be in the gray line at the bottom. So tomorrow we want to increase capacity in our network. So build new infrastructure. Of course, building new tracks is essential, but also putting more trains on the same track. And that's where we need digitalization and, of course, AI. And we want to optimize our processes. So we want to have automated processes that make use of data and AI and not scheduled processes in a classical way. And that's why we think AI can be very helpful in that matter. This slide is very useful to talk to business units and to explain what AI actually is. I think it's common knowledge for you here, but what's important is that we don't think it's just another hype or just good for new business models, but it's very important for our core processes. And it all depends on data. To perceive things out of data, to make the computer to perceive things, you have to make that data available. And that's maybe one difference to Circ. We have a lot of data, but it's not available for everyone because it's in relational databases, decentralized, and it's not accessible from one point for everybody. And so the mission from the Data Intelligence Center is to fix that. To have one access management, to have data catalog, to find that data, to have data governance, of course we have to talk about that as well, billing model and one ecosystem. And if we have that ecosystem as a basis, we can use AI to actually use that data. And of course not only AI but also classical data analytics methods, but of course AI has huge potentials in certain use cases. So we want to use it in our core processes. We have an AI strategy, which is important to communicate with the business because we have a lot of employees and people who are not that aware of new technology trends. And we want to scale those projects and move DB forward overall. Like I said, in the Data Intelligence Center, we'd like to focus on our core processes. So we are an asset-heavy company, so we have a lot of data in our processes, we have a lot of planning going on, and that's why we like to focus on those 3 areas. Provisioning, so putting our assets where we want them to be able to fulfill our service. Then maintenance, so keep them in good health. And operations, so basically train operations when we talk about mobility, so move trains from A to B. And I brought 2 use cases for those areas. The first one is visual diagnostics. This is an example for our long distance trains. And we want to detect damage or defective parts on our trains before they come into our workshop. So there's camera bridges at the entrances or at our workshop facilities that looks at the train and tries to find defective parts and pre-inform our workshop staff where they have to look at. Because today they have to manually look for defects, damage to the train, often in areas where it's not easy to get, for example at the top of the train or at our current collectors. And those cameras, with the use of AI, want to pre-inform those workshop employees. And we're using a combination of supervised and unsupervised learning for that use case, because at first we want to unsupervised cluster the damage, like what is similar, and then have our experts look at the pictures and label them and actually tell what the problem is and how it can be solved. And of course it can trigger other processes. For example, having the right spare parts brought to the workshop facilities, or maybe inform a skilled worker for a special problem, for example. And if we collect that data, we can of course predict problems. So we can find root causes for reoccurring damage, and we can maybe predict when certain damage might occur. So this helps us, that's like true for AI in general. It helps us to understand our assets, our data and our processes better. The second use case is train operations. This is interesting because if you think about a network, there's train operators working for our railway transport companies, and they decide what to do when something is not going according to plan. So there's a plan, and whenever there's delays for whatever reason, they have to decide what to do. So maybe they have to change the running order, or a certain train has to be rerouted, or has to turn back earlier, so not go to their final destination, to be on time on the way back. And they have to make those decisions in very much of those decisions in a very short period of time. So it's based on a lot of experience, and they don't have time to observe what impact their decision actually had in the end. So with AI, we want to understand the impact and the dependencies of those decisions and what outcome actually we have at the end. And we want to move train operations from expert experience to having actually proof of what decision is right in a certain situation, and then help our train operators to find the right solution, so to give advice. And what we did is we used reinforcement learning, so we simulated a part of our network, used historical data, and we have an agent that basically tries to find the best way to operate those trains. And the reward is velocity. So the assumption is that the faster the trains are on the network, the more people can, like the capacity rises, the more people can use the trains, they are more punctual. And we actually have like 10% increase in velocity in that, of course, a model simulation, but we think we can adapt it to a greater model and to production. And of course, there's lots more to do at Deutsche Bahn. Like I said, we have several different business units and very different use cases and business models, and there's a lot going on. So I think what a lot of you might know is so-called Reisendeninformation, so information to our travelers, passengers, when the next train is, on which track it's going to arrive. We use AI to improve that, or to detect snow on our platforms, and to inform services to get rid of the snow, or warehouse logistics, or customer-facing services in our DB Navigator apps, and things like that. Yeah. And thank you. If you have questions, feedback, please feel free to ask, or during the discussion.
Thank you. Let's take one question for the time being.
Hi.
Hi.
Is it? Hello? Yeah. Okay. You spoke about a single point of data, so that sounds like a massive amount of data. Like, what do you think, how many people will be able actually to use this kind of data? Because, I mean, if we think about BI software, it's already complicated enough, but I think we are speaking about much more data than a single KPI dashboard.
Yeah, that's true. So I do not mean every data at one point and being in one data lake, for example. We will have several data lakes, but what's important is getting access whenever you need it. So we need to connect those data lakes, and we have to implement processes that if you want to have certain data, that you can get it in a short period of time. Okay. That's the most important thing.
But of course we're speaking about, let's say, a higher skill set you need than nowadays to work with the data, right?
Well, it's classical data science. So what do you mean? So it's not just BI and for managers. So it's about analytics.
Yeah.
Yeah.
Yeah, definitely.
Yeah.
Because what is called nowadays self-service, it's not I'm a skilled data scientist.
It will be a mixture. Of course, we want to have self-services as well, to make data available for everyone who needs it. So the important thing is who needs it.
All right. Okay. Thank you. Cool. Then let's jump into the discussion and ask all the speakers to come in front and have a seat. So I must admit I'm a frequent scooter user. I don't know if it's because I lost or my bike was stolen and I didn't purchase another one, but I really use the scooters and I like them. And now the thing is I have several apps, several scooter apps on my phone. So Fabian, can you tell me how Circ wants to differentiate, or why should I use Circ more often than others?
So first of all, let me ask you, do you also have several car apps on your phone? Like, is this not the case for the whole sharing economy? Because in my case, that is the case. But we are also developing our API constantly, so we can actually be integrated very easily in these, let's call them aggregator apps that show you cars, bikes, scooters, and all the possibilities. So that's to answer your question of easiness of usage. On the other side, we are trying to build a scooter that is very robust, which I guess is one of our USPs, being the first ones to actually have swappable batteries on the street, scooters with those batteries. Also, we do, like I said earlier, have all of our operations in-house, so we actually know all the data, how are scooters being rebalanced, how are they being swapped, how much collections can we actually do during a day, so we have control over that. And then also we are a European business, and we focus on having contracts with the cities, with the governments to make a difference in Europe. Companies from other continents may have different strategies and that work over there, but they do not work in our cities. So that's what differentiates us in that sense.
Is that is that a competitive relationship with all the others, or are you exchanging also best practices? Are there communities of scooter companies?
So that was actually also the question I asked during my interview at Circ. And there is, so we essentially try to all pull into the same direction because, and I think the first question earlier actually showed that if you over deploy the cities and put thousands of scooters everywhere, it gives the whole market a bad image. People will stumble upon them, people might actually not be able to cross, for example, sitting in a wheelchair and there is just a couple of scooters there, you can't really go over that, and that hurts all of us. So it's not like a cartel that we essentially decided, hey, let's just do one price, it works for everyone. But I think it's obvious to all the players that when someone does something stupid, it hurts all of us, and therefore we have to align on that. Yeah.
You were telling us there was no data to learn from, right, regarding seasonality and so on. But what about the bikes? I mean, we had this hype a couple of years and seasons ago, right?
Yeah, that's a good question. And yes, we could, in theory, use bike data, but that is other companies also. They are not willing to share that data easily. And I think the priority when we started was really get into the market, collect your own data. You know how that was generated, because you want to always know the so-called data generating process. What does it actually mean if a scooter sends a weird signal from Dubai? Like, you want to know what's happening, and therefore the idea was collect first and then reiterate after.
So Circ and other cases are wonderful examples for business models, companies that are built on data. So there are now a lot of existing companies that have a lot of data, but maybe not yet are ready to use them at the full potential. So from your experience, how does it work, and what are the biggest challenges? You briefly mentioned them, but making Deutsche Bahn really AI ready, share some personal experiences.
When it comes to data, it's different layers. So it starts with technology. Like I said, a lot of data is stored in relational databases, decentralized across different business units. So we have to find a solution to make that accessible through various data lakes, for example. But of course, it's an organizational or political layer as well. So there is people who own data, and yeah, we have to show them that they might benefit if they share the data. So we have to break up business unit specific data, and we have to share the data to be able to use it with AI or other data analytics methods. We don't have to focus on AI, but that's of course the topic today, and in our use cases it showed that AI is a good way for those use cases. Yeah, so it's a lot of communication as well in a huge company like DB.
Did you had to also transform the organization to make this happen, where there's some initiatives internally to break it up, to reunite silos and things like that? Something you experienced over the last couple of years?
The idea is to use the Data Intelligence Center, which is like a competence center, an organizational form, to implement data science, data intelligence, AI in the company. But of course it takes time, and there's like 200,000 people in Germany working for DB. So of course this is just one spot, one spark maybe. But we want to create like a knowledge hub with that data intelligence center. So there's a lot of talent in those business units, data scientists, AI specialists, working for different business units. And a problem at DB often is that experience made in one business unit, in one department, is not necessarily shared with the other. And so the same experience has to be made again. So why not share it? And therefore we want to, that's our vision, of course it takes time, to create an expert hub so that data scientists can share their knowledge, because from my experience that's what data scientists want to do as well, work on different projects and see different business units and different things.
You were talking a lot about autonomous driving and also the challenges we are facing. Let's focus a little on the next steps. How do you see like the whole like trend going over the next couple of years? So what do we need to take the next step?
I think that was an interesting question about Waymo. And I think what we need is more engagement, I think, from politics. Because I think they drive already since years in selected cities and can practice. And I think in Germany it is not so easy to find, I would say, the willingness to do these risks. Okay? I think in Friedrichshafen they decided on a route through the city, for example, because I think ZF is owned by the local city. But I think a little bit, I think we have to be more offensive and looking at the advantages probably, and not so more looking on the possibilities of losing jobs and all this stuff. And I think we need that. We need more help, I think, from the government.
Is the German problem? Do you think on other countries?
No, I think it's a generic problem. I think on every country. I think especially it's even I think within US. I think it's different if you are going to California or somewhere else. But I think we should be aware if we are talking a lot on technology. I think the car is just a startup. I think as soon as a car can handle to see and to operate in such complex environments, I think the next step is a robot. And I think a robot that can really see and really act on what he's seeing, I think, will drive other markets. And therefore, I think we will have a follow-on wave after the car. And I think if we lose that battle, I really think that this should not happen. And I think it only helps to practice. I think it makes no sense only to believe that you can do synthetic data and synthetic runs.
Are there any signs that politicians, that governments are really understanding what has to be done? And are there European countries maybe leading the way, things where Germany could orient itself? So,
I think, as you said with Weimar, I think they work with California. I think most people or most companies, even I think Daimler is running in California because of the laws. And I think it's just something there should be for both sides. I think the problem we have is in investing. I think you have always this curve where you say, how is a business case on having now autonomous driving cars? I think that is a question that is always coming up. Do I invest now? And the problem is from both sides a little bit. I think that we need some joint efforts to go that way, because I think a company that doesn't see the revenue will not force, I think, these engagements. And I think that is something people from the inhabitants of the cities should have some pressure on that. Okay, that I believe.
For the micromobility sector, would you also say that the government and the regulations are too strict, or are they quite open for experimenting? I mean, there was a discussion, right? But then there was also leeway, right, to act for the companies. What is your experience?
So first of all, that really differs for the countries. So every time it's a different scenario for each country. And first of all, the regulations are really slow. Like, a lot of companies were already ready to start experimenting, and it took more time to make the market ready to actually go there. In the long run, and this is essentially what we believe, the company will win who can actually show the authorities, the regulators, that it makes sense to have corporations. So, for example, at certain locations in the city, you are actually supplying the last mile because public transport doesn't run there. And so one of the main focuses is really having these partnerships. And in the end, we will only have a couple of companies left in this right now very competitive market who will then essentially lead this movement. So it is very important to work with the regulatories. Yeah.
If we take it a little back to data, right? So when we talk about AI, we talk mostly about machine learning programs. You refer to them. So what kind of classification methods, some of them you mentioned already, are really used and where? Yeah? And how long does it really take to develop them and implement them? Can you share some more examples and insights?
Yeah, so there are some cases that I can share. So, for example, we are using the data that we get from our app, which includes the comments that users make on our scooters. And then one model that we essentially built was an NLP model that classifies these comments in either good, bad, or neutral. So very simple, but that gives us an indication of a scooter only getting bad reviews. Maybe something's wrong with that scooter. Which then also is a classification problem that we solved in terms of predictive maintenance. So we classified scooters in will they most likely break in the next 48 hours or not, based on users' comments, based on information we have about the ride, and then answering your question about how long it takes. Well, we usually go with this 80-20 approach, like really get something going, push it, and then see how it works. So we have small iterations, and I think one thing that I can tell is with this predictive maintenance, so predicting a broken scooter, is the first iteration was a really bad model. It was really just using the rating, using information you had on the fly. We tested that for 1 week while building the next iteration, which then actually had access to historical data. How were the ratings before that? How was the speed of the scooter in the rides before? And then did that for a couple of weeks and realized, okay, we can do this even better. And then the last iteration was using geospatial features. So yeah, cobble streets, like I mentioned earlier, this might break down. Classify it as broken. Because it's very important that you don't want to have broken scooters on the streets, but you also don't want to have a model where 80% of the marked scooters are actually working, and then you're taking them off the street, although they would actually be beneficial. So the fine-tuning is really more like a trial and error approach here.
Yeah, I think we do it the same way, at least when it comes to projects and use cases. We want to test our ideas in a very early stage. So there's the business problem. There always has to be a business problem. That's important. So we want to solve actual problems, and then we start with the data testing and try to find the right method that we can use, and then we try in several iterations.
I think in the early starting phase, I think it's mostly helpful if you invest some knowledge of the people who have run the process. I think that's helpful. Then you can reduce the complexity of the model, because the more parameters you have in your model, the more you have to train it, and the slower the process is. Therefore, to reduce, you have a combination of analytics with really knowledge of the process really helps. That's my opinion, and that try to do it from scratch and only build a model, throw data in, I think it's often not a very good way to do that, okay?
It's very important. That's why I said we want to have a business partner, because we need the domain knowledge to understand what we're doing and to understand what problem we'd like to solve, and to get input into the models, right, and see whether the outcome is useful.
So we all know the quality of your output is depending a lot on the input data, right? And sometimes, or very often, you have this issue of imbalance, right? So how do you cope with that, and how do you deal with such kind of data issues?
So yes, data quality, it's a big topic in our company, which actually a lot of young talents are not really aware of when they enter the company, that they have to keep an eye on that. They have to understand how the data was generated. They have to understand why sometimes data is missing. So for example, if I don't get the payment information, is this really a failed payment, or does it mean there was a voucher right? Does it mean I don't know, someone paid too much money? They have to understand what the data means. And we realized pretty early that this is not the case, because we were moving so fast and we have all of these data streams coming in, that essentially we had to build up like an internal wiki that explains how to look for data quality, how to understand your missings, how to essentially do some testing if that data is really tidy, how to get it into a tidy format. So that plays a big role, did play a big role and still does. And in terms of imbalance, I think one example that I can mention is when we were analyzing a new pricing model. So we gave away passes that give you 24-hour free rides, for example. We only had a small group of people actually buying these passes. So we didn't really know how to compare it to our other users. So what we did is we essentially matched this treatment group with users that are very similar in their ride behavior before they actually bought this pass, and then either randomly sampled those or did some averages to compare what the influence of the treatment after it actually expired was. So this is one of the cases where we had to deal with imbalance, because the group was so small.
yeah, data quality, of course, is an issue. Often because data is maintained decentral, and that's again where we need the domain knowledge to understand the data, what it really means. In operations, it's complex data, complex information, and yeah, so we have to often. Data analytics and AI helps to find quality issues, because when you actually use the data, you see what's wrong with it, or where you might have to increase in quality.
One thing I forgot to mention, which is also very important, is talk to the people who create the data, which in your case is business partners, but in our case it's just the backend engineers who created these processes in the first place and might have overseen something and you're getting wrong data, and you really have to, at least in our case, be close. The data team has to be close with the engineers to work out the details and discover faulty data.
I think in the plan I showed to you, I think the business partner in the background, I think they are planning to implement already analytics to qualify the data in the stream, because if you have driven 8 hours and then you detect that your camera has problems, I think that is not a good way to do that. But in the car, you always have the problem of power. If you are putting analytics in the car, you need a lot of power to run the analytics, and you don't have the battery power to do that, and therefore you are always in a cycle where you have to look on how the power consumption of your primary device is, and that's a very big problem with cars, that you can't put all this stuff into the car without having a reduction in the runtime. Okay, that's.
We want, of course, to include the audience, all of you, if you have further questions. But I would like to start maybe the discussion with. Looking a little into the future and maybe listen to your view on how mobility looks like in 5 years, perhaps, and who are the driving forces? So who might be the orchestrator of mobility?
The customer? I don't know. Well, it's nice to have the three of us here, because I think in 5 years. The vision for all of us should be that it's integrated mobility, because the customer, well, he doesn't decide that he wants to check train in the morning. He wants to go from A to B. So it might not matter, depending on weather and other things, of course, which form of mobility it might be, an autonomous car, e-scooter, or the train. So I think it has to be integrated, and of course the train is good for long distances, traveling fast. Last and first mile is for cars and scooters. So yeah, it has to be focused on the customer and the demand. So maybe not a schedule for every hour, but trains operating with the demand of the customers, maybe.
That's a very good point. I think in terms of the actual vehicles that we're going to see, there's going to be way more variation because of the use cases. Because of, hey, I really just want to go there very quickly, or I actually want to buy stuff. Like right now, if we need a van to move, for example, to a new flat, we rent it for a couple of hours, we put our stuff in there, and then we give it back. And this I can see being over several use cases, that you always get the right vehicle for that use case you're solving, and it's available where you actually need it. But I think it will be fewer players actually in the market. Like I mentioned before, cities will react. There will not be this over deployment of many vehicles in the cities. And also in terms of autonomous driving, I think it will penetrate more of these markets. And for example, one funny experiment that I was stumbled upon was that some companies actually use autonomous driving to rebalance the scooters. So you use a scooter, you go somewhere, and the scooter drives back by himself, which obviously doesn't work yet, but it could be a thing that's going to happen, that it can control for not falling over and all of these details. So yeah, that's my take on that.
Okay. What should I say on this? I believe that we have to reduce the complexity a car sees. I think that most companies are driving in that direction. They are building, I think, middle size. I call it buses probably, that are driving more controlled regions. And there you reduce a problem and you probably combine it in the first step with a person. And I think that is something in between the personal car driving alone and I think the very big buses. I think there's some drive in that direction to reduce the complexity, and then we will end up with, I think, a more flexible bus driving that is combined. As we said, I think this is more the smaller or the city region, and then we combine it very integrated. I think that's the right point. I think more important is integration and to go away a little bit from the absolute personal car to a shared environment there.
Yeah, we have to increase capacity on the street and on train tracks. Because like you said, there's only one person in the car and there's traffic jams and people want to, like mobility is rising, so we all want to go from A to B a lot more, travel, business trips, whatever. So, and there's, at least when it comes to Deutsche Bahn, climate change and CO2 reduction, of course, is increasing demand for trains and for train rides. So we need to be able to increase capacity, and I think that's with digitalization and integration with all of our companies.
Let's open the floor and
okay. But what are the missing steps in between where we now to some services like Clever Shuttle? Because I read a few weeks ago they completely stopped the services in a few cities just because the politicians said, oh no, this is they had some boundaries. So I mean we shouldn't increase like the capacity in terms of more cars on the street because we already have too much cars. So we need to optimize this ecosystem, and there would be something like bikes, scooters, public transportation, Clever Shuttle, Uber, and so on. But I mean, we see in the last few months and years that like the politics are always blocking this services. So
I just wanted to say, I don't mean capacity by having more cars, but to share cars. So capacity for mobility, not so for rides, not for vehicles.
Yeah, which doesn't mean more cars, but it actually means fewer cars and more parking lanes being transformed to parking spots for smaller vehicles, as an example. And in terms of politics, I think it's always this change. At first is really difficult. When we first had cars, people didn't really accept them, right? It was like, why do I need that? And the same goes for scooters right now. We don't need them, but right now it's just more of everything. But at some point it will balance, and then politics, at least that's what I believe, will also adapt and then essentially, yeah, create these parking zones the same way they now create more bike lanes, for example.
Yeah, question.
Maybe just another answer. It might be politics, but maybe also society. So people that are here in the room are probably very positive thinking about these new mobility services, but maybe not everyone. So when we're talking about the SUV debate and maybe have smaller cars in the city, you can see that a lot of people don't want to adopt that shared economy, and maybe that's an aspect as well, but that needs time.
We see already, like from society, a lot of pushing. If you see, for example, the protests at the IAA.
Yeah, things are moving, definitely.
So a question for Deutsche Bahn. So among all the use cases you analyze already, so considering the investment that you do in infrastructure, in software, resources and so on, and the benefits that you get, the company and the customers, which are the use cases you think provide the best return of investments? And how do you identify the best cases?
Well, I wouldn't say new business models, because I think, but that's always not easy to calculate business cases, but I think improving our core processes that are well, expensive in the way of putting resources and money into the processes. So whenever we create more efficiency in our core processes, so maintenance and train operations, I think that's what gives the most benefit to the company, because the strategy for the company is to double passengers, so customers using long distance and regional trains, which would have a lot of impact, of course, on the company, also on return on invest or on benefit. But to achieve that, we need to think new, basically, because with our processes today, we won't be able to double capacity, because we're not able to build new tracks, like a second track next to every track we have today to double. It's just not possible, because it needs more time. So I think it's the core processes, but that's just my feeling.
Okay, hello, my name is Christian. I'm interested in automated driving and also in AI. And my question goes mainly to Oliver from the Deutsche Bahn. So my question is, in autonomous driving, what is the plans of Deutsche Bahn regarding the railways? Why don't you have it today? Because from my perspective, it's much easier than driving a car through the streets. You have this fixed tracks and you have the system, and it's already in miniature Wunderland in Hamburg. They have it. So my question is, what are the obstacles and what are the plans of the Deutsche Bahn in this area? Thank you.
Yeah. So first of all, we have an own company, Aoki. I think a few of them are here today. Yeah. So we invest in autonomous driving as well, and try to learn from it and create value from it. But they can answer your question while the networking phase as well. For trains, well, I'm not the perfect expert for that. But of course, it's a security issue, and well, it's also technological aspects. So you need to invest in infrastructure, computer vision, so that the train can detect objects on the track, things like that. Or we have, for example, the new track from Berlin to Munich. That's a so-called digitalized track, so a lot of signals and stuff can be seen in the cockpit of the train, but there's a lot of tracks where we have signals with lights, so you have to digitalize those signals for the train to automatically understand what's happening. So there's a lot of investment in infrastructure needed, and therefore it's just not the first thing to think about.
Hello. So my question is, like, what will be impact of 5G on future of mobility? Impact of 5G on
5G?
5G, yeah, 5G.
5G.
5G on future of mobility.
Well, for DB, it's very important, because we need connectivity for example, IoT sensors and real-time data streaming and analytics with that kind of data. So it's very important, and of course for the mobility experience. So when there's a lot of people sitting in an ICE, I think it's roughly about 1,000, and everybody wants to see a movie, their favorite movie, so 1,000 different movies. You need a lot of bandwidth and 5G for connectivity. So it's important for DB.
In terms of micromobility, even in 5 years, I think the data that is essentially important for us as a company will not be that big. We're not collecting pictures, and I think it's also illegal in a lot of cities if all the scooters would have cameras. But besides that, the only thing that we care about is really like where and when and how, but we don't need pictures for that. And it would be way too much overhead in putting these expensive technologies in the light vehicles. Even in 5 years, I think we can deal with lower bandwidth, at least in the micromobility market.
From the car side, I think it will be important, but we always have the problem what to do if you are in a tunnel or somewhere and you have no. Therefore, you have always to be prepared for these situations. But it will really help if you can buffer something and move it to the background, I think. But it's really then a complex process because you get not rid of the technology in the car. The best would be to do everything in the back end. If you would have 100% 5G reception, I think you would do the most things in the back end. You know where the car is and all this stuff. But I think the problem is always that you can't really rely in total, but it will help. I think you can buffer and then send, especially I think critical situations you can analyze, you can send them to the back, and after otherwise you have to wait until you are connected in a better way. But I think in any kind a car up to now is something that is autonomous in some kind, and I think that's the main factor. I think as soon as you regulate too much where it can drive and where it can do, I think then you are ending up in something that is not, I think, that what people might expect from a car. Okay.
My question mainly concerns autonomous driving. Though it will be relevant to all three of you, how much of a push do you see to solve the issue of autonomous driving with an interactive environment rather than brute forcing it and identifying everything from the car itself? How much of a push do you see of the environment basically telling the car, I am a stop sign, I am a red light, I am a pedestrian, or whatever it is, and using interconnectivity to solve or simplify the issue of perception?
I think from the car side, I think it would be really a simplification. That's right. I think the point that you have is then you have to roll it out in a. I think it's a mass invest of the cities in such an infrastructure, and that is probably a little bit a problem. But I think there are big companies in Germany that see the world the other way around than probably the automotive providers are thinking. I think they are thinking more in interconnecting the cars and interconnecting them with the traffic lights and all this stuff. It's a good idea. But I think it will even take probably a longer time to have a sufficient supply of that technology than it might take to make a car run on its own. That's my opinion a little bit.
Or is it security, basically?
I think it is more, as we said before, the investment. I think you have to invest on both sides. You need the traffic light that is intelligent, and you need the cars that can receive it. And what do you do with all the cars that are out there and don't have this technology? And you still have the problem of a runtime of cars. Therefore, I think if you can't replace all the cars in one step, you will have 15, 20 years of cars out there that are still running, and then you have relatively complex scenarios. But I think it makes sense, as with the autonomous car, to invest in that, but you will not have the relief in the next 2 or 3 years. That's my opinion, okay? Because it's a both sides topic. Probably with the handy, I think that would be probably, there were a lot of approaches on taking the handy with you, and then the handy is your connect point. I think that would be much easier to work at that point, but I think there's the integration of handy and car is always a problem, and but I think that might be a better idea to take the device or some control with you in your car. And that's probably a problem of the OEMs that might not prefer such tight integration between mobile devices and the car. That might be a third topic. Okay.
All right. Question? One more question. Okay, fair enough. 2 more. Okay. First and foremost, thank you, gentlemen, for giving us your insight about AI, and especially transportation and where it comes to how cities have been evolving. And living in Frankfurt, especially being an e-scooter user, I've quite seen the e-scooter mobility happening just in the last 4 months, I'm assuming, that this has gone off. And we've seen multiple companies come through. And of course, a lot comes down to the user adaptiveness that you're trying to capture, I'm assuming. And then you've got the design of the scooter, which is sometimes working, sometimes not working. For example, Lime looks really good when you look at it, but when you use it, it's not really that friendly when you use it. So these are the things that, and then we have to download 4 apps just to make sure that you find the nearest e-scooter. So these are things that you guys have to work it out and see how it is. The question to you specifically is, of course, you're taking a pie from the taxi companies. Like there's a big cake being divided by these guys in terms of business, which you've come and taken off now with technology. So how easy was it for you to, of course, we've all known Germany and the lobbyism is quite strong here. Was it easy for you to negotiate with those guys? Was it easy for you to get into cities? Just one opinion from you. The next question also to DB as well. I'm also a DB user. I know the app is very friendly. It's getting there. One advice is, are you guys able to predict through AI and data the usage of the tracks? Will there be repairs coming up in the next 3 months, things like that, that you can obviously divert trains accordingly? At the same time, also, are you able to predict the usage of the trains as well? Like, will these trains in the next 3 days, they'll have some issues where we need replacement trains so that the traffic, because users don't get affected on that. That's another question. And then, of course, for IBM as well, in terms of the cars, one question for autonomous driving, very, very important thing is data. But data is all about uninterrupted flow of data. Are we still there yet as a city to have uninterrupted flow of data yet? And this is where a couple of questions where you guys can tell us one by one, please.
Okay, let me quickly tackle the first part. So essentially, what I can tell you is that we have a huge team actually doing these negotiations, actually figuring out what market would work best. And you're right, there is obviously, everybody wants to have a piece of the pie, and the taxi companies are one of those, and ride-hailing business as well, which is just not just taxis. But there are some countries that just work better, that are very quickly in adapting the rules. And Germany, for example, was a tough market to enter. But every company believed that it's a lucrative market, it's a promising market, so we do whatever it takes in that sense.
Okay. The question was whether, well, let me put it that way. Everything you mentioned, we are on it. So we try to solve that. And people are working on it, especially passenger information. There are a lot of people, also data science, working on IT infrastructure to make the data available, because when you talk about maintenance of tracks, that's data from DB Netze, who owns the tracks, who maintains and operates the tracks. But passenger information is needed for mobility, so for trains. So you have to make the data available, and then you have to predict. And people are working on it, and it's getting better. And we also try to predict how many people are on the trains. And you can already see that in the app and online. But of course, we need to improve that information as well. And we have to put a lot of different data sources in there. So how many people bought tickets, historical data, how many people use the train, maybe event data when there's a football game or something. So it gets better every time. So the infrastructure is there, but yeah, the quality of the output that you see in the app is hopefully getting better and better.
I have a question. What do you mean with uninterrupted data stream? I think in the moment the most investment is on autonomous, and then the information when the car is run is mostly inside the car. I think nobody relies in the I don't believe that a lot of people rely on the on the time frame you think on any back end. I think in the long run, in optimization, where to drive, on which street to take, I think that is more the minute or 10-minute scope. I think there's a lot of information to the back end that is already running. But I think in the time frame you are thinking, I think it is the time you have is so short. I think that will, to my opinion, be autonomous reaction. Otherwise, I don't believe that you can tell somebody that he lost his life because of a network outage. I don't believe that he'll follow on that. But it's an interesting point. I think we get better probably with 5G in the combination of both. That you have on one side a recommendation within the car and a recommendation from the outside. That would be very interesting. Okay.
As we had now 3 questions instead of 1, so we took already 2 more. I really suggest, given that the time is now quite advanced, please have your questions answered directly in person to our speakers. Thanks a lot for your presentations, great keynotes, and the discussion. Thanks. Vielen Dank.
Danke.
Ja?